So I've managed to get one of these safes. I've only taken out the door out of it. I haven't taken the entire safe. It's an Ilco safe, and the standard thing that you get in a hotel where you enter your code. Obviously, it's pretty old, fairly gone through, so you can't actually see numbers on several of these. And then there's some sort of unlock, I assume, programming type port there. Looks, well, it's not quite a Cat6, so it looks like what? One, two, three, four, five contacts. It's a bit odd. Normally telephone had four. And what you will notice, the first thing you notice, this door, the metal, is probably about 4 to 5 millimeters thick. The actual body of the safe is only about 2 millimeters thick. So the worst thing you can try to do is come through the door if you're trying to break into a safe. It's terrible. If you look at these, look at the size of those pins. I mean, those are very significant. You're not coming through the door. That's just not the way to go if you're going to come through a safe. So the back here, we can see the battery compartment, and there's some security docks, two here and one on this side here. I don't have my kit. I'm hoping to be able to find a way through that somehow. Let's open it up and let's see if we can figure out how to actually, how it works. Maybe how to break into one of these if you had to. And this is the 3 bolts. This is how the door is connected onto the body. As I said, I've left the body. So let's get on with it and see what we can learn. So that turned out to be a little bit easy to open. Battery case, contacts coming out, jumper to here. I mean, everything inside here is corroded. This has been out of service so long, it's really, barely even sustainable. So the motor turns, goes up, gearhead motor, I assume, most likely it's a gearhead motor. We'll have a check on that. And that will cause this to go up, which will push this out. Makes sense. That's regulating the slide in here. And breezed up, 2 pins go out. Those pins aren't going to come back in by just pressing against this. So again, that too doesn't seem like a good solution to get in. This interestingly has a switch. Didn't expect that actually. So I'm going to cut this out, pull out some of these jumpers, and then there's a board. Looks like a programmable chip. I would assume it's a programmable chip. Fairly basic, simple surface mount components on it. So this has to be pretty old setup. And then this ribbon goes into the front where the keypad is, and I assume that's just a keypad. I assume there's not really much could be gone from there. But let's just see how secure it is. It does look like this is a full metal plate onto another metal plate with this piece bolted on. So I suspect if you were to break that keypad, all you will get access to is this little slot, which doesn't even get you it because there's a piece of metal here. So I suspect that's how they've done it. So that is probably not the point of entry you'd want to try. So there's quite a few jumpers. As we said, we took off the one for the battery. This is the on-off switch. This is the motor. This one is going to this device here, which we don't know what that is. So we'll figure that out. There's a connector here going to something in the front. Again, not sure. This is 1, 2, 3, 4 connectors. Maybe this is the programming connector. Who knows? Is it written there? It says over. Not sure what that means. All right. And then there's this one. It says amp 1, 2. I assume again this is the keypad. So let's see what all these connectors are for, how they put together, why it is that there's so many different items. So I've taken the board out, and that's how it looks. I'll take a photo and leave it at the end, and we can see a buzzer too to give some kind of feedback. At the bottom of it, single side surface mount components, right? Well, this obviously someone's made a boo-boo somewhere and did a jumper, but yeah, pretty much single side surface mount, and there's some unpopulated spots. Chances are there's some other additional features to go in. There's one little chip there, what looks like a programmable chip. We'll do a little search and see if we could find anything on this, but I suspect not, because this number is probably just a number from the manufacturer of the safe as opposed to the chip manufacturer. Chances are we probably won't be able to tell. This piece that we were trying to figure out, well, it's the extend switches. So that little tab touches it when it reaches fully out, stop the system, this fully in, stop the system. It's just 2 contact switches. So yep, things have come in more clear. So we've taken this completely off, and as you can see, it's quite smooth, very easy to move. So that means that motor doesn't have to be as powerful. It's well lubricated. It looks like a silicone type grease. That looks yellow. Who knows if it's a silicone type? I normally just assume yellow types is more petroleum based, but this is moving extremely easy. I mean, little finger, look at that. So that's that mechanism, and there isn't very much else to see. These two are riveted on the bottom. If we have a look at there, you can see. Just now, let me see if I can flip this. Right, it's just a panel with some pieces pressed in to screw thread on into. Then it reveals these, again, studs that I assume are just welded in, and there's some screws. So that allows us to take out the front. Quick one on the motor, you can see a manufacturer, right? What is it? Taizing, and there's a telephone number, interestingly, not a model number. Again, how is this looking? This is, yeah, I would pretty much say definitely a gearhead motor. Fairly simply put together, actually. If you look at it, it's just a wedge that's keeping that in, and the shape of this casting. And this casting, I doubt it's aluminum, but it's gonna be one of those cheap metal castings for sure. So we can see the ribbon does come from this board, which came in from the keypad to here. So that is the keypad. The 4, which is what we suspected, was this connector with 5. I'm not sure why there's 5 connections in here and only 4 here, but yep, that made sense. This one, unclear. Not sure if it's just power to light up the illuminate the button so it's easy to see. So let's have a look. Let's see if you can learn anything more. So it looks like we're correct. It looks like this is for the LEDs. It's an interesting method. I've never seen that before. They've just bent in 4 LEDs, saw them and just bent them in there and left this, which is translucent material, so the light gets in and you, I guess, glows a bit. And then we have the displays. These are the 7 segment displays, and there's 3 per block, 2 blocks, so 6, 7 segment displays. Nothing much else we'll see here. Nothing much else to see. Again, it's a matter of seeing if you can get some information on that IC, which who knows. Well, if we take off the actual little sticker, there's a full number here. I suspect I can find this. I guess they weren't too concerned about hiding that, otherwise they could have easily just removed this. Well, it turns out this is a microcontroller. Put up a link and just a snip of the spec sheet on it. It's pretty much 2.7 to 5.5 volts. So yeah, works with the 4 batteries, 6 volts, and this happens to be a time clock, which I found surprising. I didn't expect that you needed to have one of those, but that again works from 2 to 5.5 volts. It's a serial timekeeper chip. Apparently it gives day, month, year. I'm not sure why that's really necessary for a safe, but for some reason it is. So yep, that's the 2 little chips there. The rest of these are all passives pretty much. There's a jumper there which seems to suggest that may be used for reprogramming a chip, and I suspect it was through the port that we looked at earlier you'd be able to reprogram, but that would then, I guess, if you put it in one position you'd be able to program. That's my guess on that, not really sure. And mostly passives, a couple of transistors, quite a few transistors actually, but not the most complicated board in the world. Not that I have done a proper check of it and what everything does, but yeah. And there's of course a crystal next to this time clock. Surprisingly that it needed a time clock and it needed a crystal too. You would think that works without, but I guess it doesn't. So not much we can really see past that. In terms of breaking in, doesn't look really feasible. Honestly, if you were to break the plastic piece outside, you would hit the metal. You'd get a little sliver of a hole through which there's, wires that you supposedly, if you know what you're doing, can push something in and hook that little bar that we showed earlier and pull it across against the motor, which in itself may be difficult. Without the motor, easy. With the motor, not so much.